Welcome, everyone. Today, we're taking a highly structured, totally cosmic journey through the foundational building blocks of mathematics, specifically Form 1, Chapter 2. In this explainer, we're going to explore the hidden architecture of numbers. Think of numbers not just as flat, boring symbols on a page, but as complex galaxies held together by invisible gravitational forces and expanding outward into infinite orbits. Okay, let's dive into this. Here is our star map for today's focused exploration. 1. The gravity of factors. 2. Prime factors in trees. 3. Highest common factor, or HCF. 4. Expanding outward with multiples. And finally, 5. Lowest common multiple, or LCM. Section 1. The gravity of factors. Let's begin our first phase. We're starting by looking inward, at the gravitational forces that pull a number together. Before we can build outward, we have to understand what makes up the core of any given number. So what exactly is a factor? Basically, a factor is a whole number that can divide into another number completely. I really want to emphasize that word completely. There is absolutely no room for remainders in this mathematical gravity. If a number leaves a remainder behind, it simply isn't a factor. It just doesn't fit the core structure. And this brilliantly illustrates that rule in action. Think about 36 divided by 12. That equals exactly 3. Because it divides completely, 12 is officially a factor of 36. Now, contrast that with 30 divided by 9. It gives us 3, sure, but it leaves a remainder. And because of that messy leftover, 9 is definitely not a factor of 30. It's a simple, universal rule. Section 2. Prime factors and trees. Now that we've got a handle on basic factors, let's dig a little deeper. Some factors are indivisible, acting like the fundamental stardust that makes up everything else in the math universe. We call these prime factors. Prime factors are literally just factors of a number that are themselves prime numbers. Let's take the number 18. The regular factors of 18 are 1, 2, 3, 6, 9, and 18. But if you look at that entire list, only 2 and 3 are prime numbers. So the prime factors of 18 are just 2 and 3. They are the absolute bedrock of that number. A really fantastic way to math this out is by drawing a factor tree. We're essentially breaking a number down step by step until only prime factors remain at the very bottom. Let's do this together for the number 60. Step 1, we split 60 into the product of two factors. Let's use 4 and 15. Well, neither of those are prime, so we keep digging. Step 2, we split 4 down into 2 and 2. Perfect, those are prime. Step 3, we split 15 into 3 and 5. Also prime. So for our final step, step 4, we just collect all those bottom-level prime numbers. The prime factorization of 60 is 2 times 2 times 3 times 5. Section 3, highest common factor, or HCF. So we've mastered the internal gravity of a single number. But what happens when we start comparing multiple planetary systems to find their greatest shared core? When determining the highest common factor, or HCF, you're looking for the largest common factor shared by two or more numbers. And you have a really handy trio of tools at your disposal to find it. You can list the common factors, you can use repeated division, or you can use prime factorization. I highly recommend memorizing this complete set of tools, as they are incredibly reliable for solving problems on your exams. Now, what's really interesting about this is how visually aligning the lists makes the highest common factor just pop right out at you. This is the first method, listing. If we have the factors of 18 on top and the factors of 24 on the bottom, we can just highlight the ones they share. They both have 1, 2, 3, and 6. Those are the common factors. And since 6 is the largest number they both share, 6 is the highest common factor. It is simple, highly effective, and honestly deeply satisfying to figure out. So far, our journey has been entirely inward, breaking numbers down, dividing them, finding their absolute core. But what happens when we stop dividing inward and start expanding outward? Before we blast off, we need to firmly establish the difference so we don't get lost. A super common trap for students is confusing a factor with a multiple. So let's look at them side by side. Factors divide completely into a number. That's the inward pull we just studied. Multiples, on the other hand, are the result of multiplying a number by an integer. That is outward expansion. Factors shrink down, multiples build up. Section 4, expanding outward with multiples. Let's move to and see how this builds our next crucial concept, framing multiples as infinite, expanding orbital paths. So, a multiple is simply the result of multiplying a number by an integer, and importantly, not a fraction. Because integers include negative numbers and 0, multiples can actually stretch backward too. For instance, the multiples of 3 aren't just 3, 6, and 9, they also include 0, -3, -6, and -9. It's a continuous rhythm stretching out in both directions. Section 5, Lowest Common Multiple, or LCM. This brings us to our final destination, the precise moment where these expanding orbital paths perfectly align. Let's use the listing method again, this time to find the LCM of 3, 8, and 12. First, we map out the multiples of 3. 3, 6, 9, 12, 15, 18, 21, 24. Then the multiples of 8. 8, 16, 24. Finally, the multiples of 12. 12, 24. Do you see it? The separate paths of 3, 8, and 12 all eventually converge beautifully at the exact same point. The lowest common multiple is 24. You can also find the LCM using the repeated division method. Let's try it for 3, 6, and 9. Step 1, we divide them all by 3, leaving us with 1, 2, and 3. Step 2 is where an absolutely critical rule comes in. We divide by 2. Now the number 2 divides nicely to become a 1, but the 1 and the 3 cannot divide completely by 2. The rule is, numbers that cannot divide completely are just brought down for the next division. So we literally just bring down the 1 and the 3. Step 3, we divide by 3, bringing our last number down to a 1. The division continues until all quotients become 1. Finally, step 4, we multiply our divisors on the outside. 3 times 2 times 3. Our LCM is 18. We've explored the inward gravity of factors and the outward expansion of multiples, uncovering the invisible structures that hold numbers together and predict their intersecting orbits. It's an incredibly organized, beautiful system. But I want to leave you with a final thought to ponder. Since these cosmic rules of factors and multiples govern our math so flawlessly, where else in the rhythms and cycles of the universe might we see these exact same patterns perfectly align? Whether it's planetary orbits sweeping past each other, or just figuring out when two different buses will arrive at the exact same stop, keep looking for the connections. Thank you for joining me on this explainer.